Hello again, you who are participating at home. The thing we're going over right now is the product rule. And the product rule says that if we have the product of two functions, and I've got the proof of it right here, if we have the product of two functions, then the derivative of it is the first function times the derivative of the second function plus the second function times the derivative of the first function. And what it is not the product of the two derivatives. A couple of examples we did in here is we said we were going to let g of x equals to 3 and h of x equals to x squared. And we learned from a previous shortcut that with the constant multiplier rule, the answer should be 3 times the derivative of the second term, which would be 3 times 2x, which is 6x. Now, we take the same problem here and we prove it with the product rule, which is the first time the derivative of the second plus the second times the derivative of the first. And we say, okay, well, we know the first term is 3, and then the second function has its derivative is 2x. So we get 3 times 2x, which would be 6x. And then we go into the second term times the derivative of the first term. The second term is x squared, and the derivative of the first term is 0. So x squared times 0 is 0. So our final result here is 6x. Now, another example we looked at, and we proved this in class last time, we're going to let 3x be our first term here, and sine x, which was what we proved last time, its derivative is cosine of x. So we've got this first term, which is 3x, times the derivative of sine of x, which is cosine of x, plus the derivative of the second term, which is sine of x, times the derivative of the first term, which is 3. And to rewrite that, because we typically like to put our trig functions at the end, we get 3x times cosine of x plus 3 times sine of x as being the final derivative there. So the next thing we're going to run into is the quotient rule. So the fifth shortcut is the product rule. The sixth shortcut is the quotient rule. And for the quotient rule, again, it's like the product rule in the fact that if I have that 8, what's wrong?
Do you mean the 6th?
What did I say, the fifth?
Yeah.
I never have been good with numbers. H of x, this is the sixth shortcut. H of x equals f of x over g of x. We've got that h prime of x is not f prime of x over g prime of x. H prime of x is going to equal to the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x all over h. Again, that's just the limit definition of the derivative. H of x is f of x plus h, so this is h of x plus h minus h of x over, and this h right here is not the same h as this h here. I'm glad that that's not confusing.
Yeah, not confusing at all.
All right, so let's go from here and solve this out. I'm going to add a step in here just because I want to show every step. I'm going to turn this into f of x plus h over g of x plus h minus f of x over g of x times 1 over h. In other words, I'm pulling that divided by h as a multiplication of 1 over h. All right, now, on the inside here, I'm going to look to make this into one fraction, which means I need to get what here? Common denominator. And what would be that least common denominator with g of x plus h and g of x? Yeah, g of x times g of x plus h. So I'm going to take this first fraction here, and multiply it by g of x over g of x. And then multiply this one by what? All right. Are we okay to keep going? All right, so now I can combine these two into one. So I've got the limit as h approaches 0 of g of x times f of x plus h minus f of x times g of x plus h all over h times g of x times g of x plus h. Are we okay to keep going here? All right. Well, I'm going to do just like what I did in the product rule. I'm going to add 0 to the numerator, but again in a different form. So I'm going to take the limit as h approaches 0 of g of x times f of x plus h, and I'm going to subtract from that g of x times f of x. So I've got to add what here? Someone say g of x times f of x.
G of x times f of x.
All right. And then I go back to the original and bring this back down, so it's minus f of x times g of x plus h all over h times g of x times g of x plus h. All right. So again, I just took that and I added 0 to it. Well, in the last problem, I had one long fraction and I split it into two. So let me split this into two different fractions. Still the limit as h approaches 0. Of g of x times f of x plus h minus g of x times f of x, and it's all over g of x times g of x plus h times h, and then I'm going to add to that. I tell you what, let me subtract. I'm going to factor out a -1 from this. Actually going to factor out a negative f of x. So if I factor out a negative f of x, this term becomes positive, so it's g of x plus h. And this term, again, I factored a negative out of it, so it's going to be minus g of x all over g of x times g of x plus h times h. Is everybody okay here? Again, I'm not asking you to repeat what I'm doing. I'm just asking you to try to follow along as I'm doing it. Okay, so let's look at this first fraction. Does anything jump out at you that we could do here? I could factor a g of x out, right? Well, I'm not going to factor it out, because if I factor it out the top and bottom, I'm going to go back to combining these into one fraction, and I'd end up having to multiply by g of x over g of x again. So I'm still going to try to keep my denominators the same so I can combine them back into one fraction. But yeah, I could do that. That would be fine. But again, I'm cheating because I know where I'm going with this. Y'all are seeing this for the first time. So it's g of x over g of x times g of x plus h, and then it's times f of x plus h minus f of x all over h. And then over here, likewise, I'm going to have the limit as h approaches 0 of f of x times g of x plus h minus g of x over, and I don't know why I wrote that as two separate fractions right there, g of x times g of x plus h times h. Actually, I do know why I did, but all right, so what is the limit as h approaches 0 of what I have right here? Well, it would be g of x over g of x, and what would happen to g of x plus h here? No, not 0. It'd be g of x. All right? Now, what is the limit as h approaches 0 of f of x plus h minus f of x over h? No? Well, again, what is f of x plus h minus f of x over h as the limit as h approaches 0?
The derivative.
Derivative of f of x, right? So it's going to be times the derivative of f of x. All right, minus. Okay, what is the limit as h approaches 0 of f of x over g of x times g of x plus h? Just that part.
No, that's the derivative of g of x.
Say that again.
Is that the derivative of g of x?
It's going to eventually be, but I'm just looking about this part first. That's just going to be f of x over g of x times g of x. Because, again, that becomes g of x when h approaches 0, right? And then the limit as h approaches 0, like you said just a second ago, the limit as h approaches 0 of g of x plus h minus g of x over h is,
The derivative of g of x.
okay, so g prime of x. So, in the end, this would be g of x times f prime of x minus f of x times g prime of x all over g of x times g of x, right? And what is g of x times g of x? G of x squared, right? So we get g of x times f prime of x minus f of x times g prime of x all over g of x squared. Oh, there's a glare on that. Let me see if I can take the glare out of it. Nope, I can't. All right, so this one's a little bit more complicated than the product rule. And the product rule is the first time the derivative of the second plus the derivative of the first times the second. And the order didn't really matter there because it's all multiplication and addition. They were commutative. But subtraction and division are not commutative. So the order that we put this in matters. So we've got the g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now, there's a different way to memorize this. And I don't like the word memorize, but sometimes you just got to use that word. If I have it set up like this, think about this as being the numerator, and the numerator we're going to call high, and the denominator we're going to call low. And if I say d something, I'm referring to the derivative of that thing. So let's think about this as being low d high minus high d low, and then you're going to go down under and square the low. So low d high minus high d low, go down under and square the low. Okay, I want y'all to think back to what was one of the earliest things that you memorized? What was one of the earliest things in your career that you in your life that you memorized? The ABCs, right? And how did you go about memorizing the ABCs? A song, right? So songs help us memorize stuff, right? Now, when you got a little bit older, you also learned the Macarena. And with that, there was a dance that went along with it. So, a good way to memorize something is song and dance. Now, I just so happen to have a song and a dance that goes with this.
Oh God.
But y'all wouldn't be interested in seeing that, would you?
Oh, absolutely.
Absolutely.
Y'all would?
I want to see you dance.
Okay. Y'all can see it. Oh, it's on YouTube.
Oh.
So it's going right here. Yeah, because I'm recording this. This is for you, Kyla. I've never recorded and put this on YouTube before, but this one's for you, Kyla. Now, by the way, this is audience participation. So those of you watching at home need your participation as well.
Don't have to.
But I need a little rhythm going.
Okay.
Come on. Come on. Low-D, high minus high-D, low, go down under and square the low. Thank you.
What?